All right, so in this video, we're just going to identify a few of these parts of the circle. So let's do the first one. So it says identify the following. So where is the center of the circle? So the center of the circle is right here. Oh, let me do this one. Where C is. So the center of the circle is C. Now what's a chord? Well, the chord is the line that the segment touching the ends. Well, the ends of the segment is touching the circle. So this figure is lying on the circle, and so we will see that. Go for my pen. So here we go. Let me change the color. Let's see. So I'm going to highlight where is the segment. So not the segment, the chord. So the chord is Fs. So Fs is a chord. All right, so let's look at the tangent. Now the tangent is the line that intersects with the circle. And this line is outside, like right here. This is RT. So we say RT. The point of tangency. Now, the point of tangency is just one point, is just the location at which the tangent and the circle meet. They touch each other. It is at P right here. And it touches it one time. So how many times does the point of how many times does the tangent touches the circle? One time. So the point of tangency is P. Where's the secant? Now the secant line is a figure that contains the chord, which is SF, and the line, which is AB. So we just say AB is a secant. The diameter is diameter. The diameter is the one that goes through the center. So which is MN. Or you could say NM. It doesn't matter which direction you want to go. Oh, there's one more that we want to look at. What is the radius? The radius. Now, the radius could be any one of these three. It could be CB or CM or CN. So we could say CP or CN, or we could say CM. And so there you go. Just looking at, just identifying the different parts of the circle. All right, let's look at something else. If I have a circle and I want to, let's spend some time with the diameter and the radius. Now, if I have a diameter of, let's say, 8 centimeter, and I say, what is the distance of the radius? Now, if I were to give this radius, this diameter a name, I could just call this SR. I could say C. What's radius? So I could find the. So if we look at this, we have two radii. We have CS, and we also have CR. It doesn't matter which one you want. Now, there's a formula to find the radius. Now, the radius is always equal to half of the diameter. So what's the diameter? The diameter is 8 divided by 2. So our radius is going to be 4 centimeter. So you're going to be 4 centimeter. Here is going to be 4 centimeter. And when you add them, it gives you back the diameter. Let's look at another one. If I have a radius of 10 centimeter, what is my diameter? No, there's a formula. There's a formula to find the diameter. So the diameter is equal to 2 times the radius. What's the radius? The radius is 10 centimeter. So all I need to do is to do this. So right, the diameter is equal to 2 multiplied by 10 centimeter. So we said 2 times 10 is equal to 20 centimeters. So this side is also 10. So that's another way you could do it. You could just extend this and just say these two must be the same. So we get 20. All right. If I have, let's say I have a line like this, and let's say, I have a center like this, and I have my tangency right here to that, probably see. And I ask, let's say it's a circle, we have a tangent outside, TR, and I say, how many times? How many times does or let me just write it in a better way. It's simple say how many times. Let me put my checks right here. So I could just simply write how many times does the tangent touch the circle? Or I could probably ask a question like I could see couldn't say how many points of tangency, how many points of tangency um how many points do we see, or how many points of tangency all right, we could say do we see, let me gonna phrase it a different way because I was trying to write this a different way because it could have been written in a different way. How many times does the tangent touch the circle, or how many points of tangency do we have when the tangent and the circle meet or intersect? And this is a simple observation. We could write this in many, many ways. So we could just start from here. We could just only read that and stop, or we could actually read this part of it. Where's this word coming from me? I'll do when the tangent and the circle or meet. Could write the word meet or intersect. We could have written this so many ways. So all I want to look at is how many points. How many points are we seeing? Now, if you look at this carefully, when the tangent and the circle intersect, it touches 1 point. There's only 1 point. Only 1 point. Only 1 point. Only one time. One time. Only one time. Only one time. This is always so. Only one time. Only one time. Only one time. Right? Only one time. Now, if I draw another radius and I say, if this radius is 2, well, this is not joined to scale. How much? So if I have, let's say, P right there, so if I have F right here, and I say, what is the distance of the radius CF? You should be getting this like, you should answer this in 1 second. So it's going to be 2. Because these radii are always equal. Let's look at the other one, another question. Now, are these circle congruent? So if I have a circle looking like, if I have two circles looking like 1, 2, 5 meter, let's just say 5 meter. Let's just give it a euro. Are these congruent? Yes, they are congruent. How do we know? When two circles have the same radius, the radii are the same, they are said to be congruent. So yes, they are congruent. Yes, they are congruent. And there you go. That's answering a few topics that you might see coming similar on your test or on your quiz, or any form of examination. And so there you go. We're looking at a few examples, very simple, very easy, reviewing from what we learned, and then we're just doing the application of what we covered. So stay tuned for more videos. Remember, like, share, and subscribe. See you next time.